Welcome, everyone. This is an Across Bridge 101. And before we get to Across, though, we're going to take a step back and talk about the reason why Across exists in the first place. And we're going to start off talking about blockchains, layer ones, layer twos. And if you're not really sure what I'm talking about, that's okay, because we're going to try and give some explanation to it. At the end, we've got like a teaser. I've got a little clip of how relayers work in the Across system. And this is very much like the introduction to Across Bridge and relayers. And we will have other workshops which will get more technical, and I will need the help of people like Dixie to do the setup and how to run relayers if that's what you want to do in the future. But this one is very much a 101 introduction to the Across Bridge. So let's get going with like definitions of different things in the blockchain world. Starting off with blockchain. So does anyone want to offer like a succinct description of what a blockchain is? EB, do you want to have a go?
Thank you, and I was kind of ready for it. For anyone to understand what blockchain is, it is essentially a ledger which has an incoming entry and outgoing entry. It is a record of balances where all the assets or values which are part of the blockchain, they get recorded, and all the data which is recorded is in the form of blocks from the data blocks. And since each block starts, it is in form of a chain. Every block is subsequent to the previous block, and so on and so forth. That's why the entire name in itself, which is block and then chain, becomes blockchain. I hope that is simple enough.
That's a good start. Hey, Dixie, do you want to delve into the world of blockchains and explanations?
I can add a little bit, I guess.
The reason I'm picking on people is just to give like different perspectives of these things so people will learn in different ways.
So I was thinking like the blockchain in the name is like it obviously points to a specific kind of structure or architecture of what it is. But I kind of see it as like generically, it's like a system that allows decentralized actors to agree on things that have happened in the past. And the way that that is done, like there's a consensus mechanism for that. And then there's like a data structure that represents historical events. And I guess that's kind of like maybe a bit of an abstract description. That would be my shooting from the hip response.
Yeah, nice. Absolutely spot on. Just one major thing, really. And it's really the decentralization part of it, the distributed part of it. So we're talking about a ledger. So it's a record of transactions. Now, if you think of traditional banking and finance, if I want to send EB $1 million to his bank, but my bank in England doesn't know his bank, how does that work? My bank knows about me, his bank knows about him, but that's it. What the blockchain does, and specifically a public blockchain, not a private blockchain, which does exist as well. A public blockchain is a distributed ledger that everybody can contribute, everybody can look at the transactions and verify. So in that way, it's much more powerful than having these private blockchains or if private databases that the banks hold about me that don't know anything about EB. On the blockchain, I can send EB this $1 million through the blockchain, and it's completely decentralized, distributed ledger system. EB, did you want to say anything else?
If you have to explain it simply, yes, it is probably a distributed database which has record of transactions, and it is widely distributed. Now, let's suppose the same ledger, and let's suppose there's one entry which is different from what others have. Okay, let's suppose we have Ethereum or any other blockchain, and one of the actors ends up changing one of the entries. Though that can be called as a fork of the blockchain because it does not have the same information which the rest of it has. But why it does not become the main blockchain is because the rest of the actors or the rest of the people who are maintaining the information which is part of that blockchain is not in sync with what that one actor has. And obviously, because it's not what is accepted to rest of the community, that's why it does not become the main blockchain. I just wanted to bring it up because everybody is talking about merge, so wanted to just throw in how there could be different forks of the blockchain, also soft forks in terms of when the data is not the same, and then you have hard forks out, but that's obviously for a different uh, conversation. But this was just about that any information which is there, it has to be same on all the different nodes where the ledger exists. It's shared, it is immutable, and has to be transparent, obviously decentralized, which form the pillars when we speak about decentralized blockchains as such.
Indeed. And you're really talking about the consensus layer and how the different nodes, and that's what they're called, these computers that are running the database, the ledger, and how do they reach consensus. And currently, Ethereum, just like Bitcoin, uses proof of work. And you've got these cryptographic puzzles, in a sense, that gets increasingly harder for it to be mined. And that's how the whole system works, but it uses a lot of energy. And Ethereum is in the process of now, hopefully it'll be really successful next week, moving to a proof of stake model. And this is where you need to stake your Ethereum and you have to do the validations. And if you do things wrong, you'll get punished, you get slashed. If you validate correctly, then you get rewarded. And it uses much less energy than the proof of work. So that's the consensus mechanism. And the more distributed, more decentralized you are, and Ethereum is probably the most decentralized, running on thousands of nodes around the world, and it's not controlled by any central authority. And this is important for when we start talking about across and layer twos, because Ethereum is known to be the most secure. Now, this brings up the blockchain trilemma, it's called. And there's three parts to this, hence the trilemma. And there's three aspects of blockchains: security, scalability, and decentralization. And the holy grail would be if you could have the most secure, the most scalable, and the most decentralized blockchain out there. But normally you can get two of the three. You can very rarely get three. So in terms of Ethereum, it's highly decentralized. It's very secure, but the scalability is where the issue is. It only does a few transactions per second compared to, I can't remember if anybody knows off the top of their head how many transactions. I think it's like quite a few. Is it 12 or 13, or am I thinking of Bitcoin now?
And generally, the number that we consider is around, I think, 17, which is
17.
mostly popular, but I'm not really sure. It could
Yeah.
be around 11 as well. So,
Yeah. So
sorry.
there's this. So it's not highly scalable. So what's happened? We've got these layer two solutions now that's come up. So some of them, like Polygon, it's what's called a sidechain. It's got its own consensus mechanism, and it's got its um, own token, Matic, which is used for consensus. But that has problems because obviously it's very scalable, but it suffers from decentralization. And very early on, when Polygon, when it used to be Matic, did have some issues when there were attackers who were able to hack the system. And if people remember, not so long ago, Axie Infinity, who runs their own chain called Ronin, had a $600 million hack, and nobody really noticed it for a while. And that's because it's highly centralized. There's only a few nodes. running. I think there was like 11 nodes, and the attackers did what's called a 51% attack, were able to get 51% of the hash rate, and this is what the computing power of that, and able to drain it of $600 million. So Ronin, highly scalable. And one of the issues, the reason they created it was because Ethereum was much more expensive. So there is this ongoing issue between security, scalability, and decentralization. And this is where like optimism and arbitrum comes in. What they do, they're not a side chain like Polygon. They build of on top of Ethereum. So they are using Ethereum's security layer. But what they do is, and in different ways. Actually, Optimism Arbitrum, they do it similar. They do what's called optimistic rollups. And optimistic rollups, as the name suggests, they will get a number of transactions and bundle them together. And then every so often, they will send it to the Ethereum layer. So in that respect, it will, for the end user, it's kind of really fast most of the time. And then only at some points will it be sent to Ethereum, and that saves gas costs, obviously. The issue with that, though, is it's very easy to send from Ethereum to Optimism or Arbitrum your ETH or other tokens. But if you want to send it back to the Ethereum layer, there's like a 7-day waiting period. And that 7-day waiting period is for what's called the watchers to check whether there's been fraud happening. And so it takes a very long time to come back onto Ethereum. Now, there are other methods, and there's not just optimistic rollups. There is zero knowledge proofs as well. And Polygon, I don't know if anybody's played around with it. They're coming out with their own kind of zero knowledge, and that's using mathematical proofs to verify that transaction is actually correct or not. But again, they have to go back to the Ethereum layer. So this is where we can talk about the Across now. So Across comes in, and the way Across works is a depositor wanting to go from, say, Arbitrum to Polygon. Usually this is not possible, but with the way the Across bridge works, and with it's called a hub and spoke model. And I'm going to show you a picture of that so people can more easily find. So just give me 1 second. So I'm sharing my screen here. Okay. Actually, just before I go on, this is where you should come after this to get more in-depth knowledge about Across. So if you come to docs.across.to, and it explains it. If you really want to get into the techie aspect of it, there's a 60-minute explainer video, which is highly recommended. And the slides are there too. I'm only going to use one of the slides here to explain everything. And I think it explains it really well. So in the middle, you've got the hub pool, and it's on Ethereum. So all the liquidity is on Ethereum. You've just got one place. In other bridge or on other bridges, what you have is that they will have liquidity on several of the chains that they bridging to and from. But this concentrates the liquidity on Ethereum, and it's much more capital efficient in that respect. And then what you do, you have these spoke pools on all the different bridges that here is showing Optimism and Arbitrum, but obviously we have Boba Network as well. And between them, you've got these adapters that connects it to the hub pool. So if I want to send from Arbitrum to Optimism, then I will deposit my, say, 50 USDC on Optimism, and then there's relayers who are looking at where people are depositing and where they're wanting their money. And it's, say if I'm running a relayer on Optimism, then I will see that and I will give the depositor their funds at the other end. Notice there's no waiting for these 7-day period. This completely take that step out. So for the user, it's great. They can go from any, basically it's from any layer to any layer. So Arbitrum, Polygon, Optimism, Boba. So it doesn't really matter because you've got these relayers running on all the different networks layers. Now, if there are any kind of challenges to, and there have been a few issues where people have actually raised objections to kind of doing the validating the bundle, and it will go to the optimistic oracle and it will be verified there whether a transaction, something is valid or not valid. Now that doesn't hold up the system because if a bundle is goes to the optimistic oracle to get verified, then it gets deleted from thing and a new bundle is proposed. Now we do have a few people here who have much better knowledge than me. So if anybody wants to dig in how this works, that would be awesome. If you're able to talk. Or if anybody has any questions.
Hey EA, your keyboard's coming through like really loud. Just to let you know, heads up.
Oh, thanks, EA. I was wondering what that was. Hey, Dixie, do you have anything to add to my explanation about how the system is for the cross bridge? If you're able to talk.
Not a lot. No, I don't think so. It's I think it's an interesting system because the design of it, like one of the things that I think is really fascinating is like one of the issues with smart contract platforms in general is that you have this risk if you make your contracts too complicated and too advanced, then one, they can be really difficult to update, and you might start using it and then you discover a bug later on, and that's like a nightmare and can result in loss of funds and all kinds of issues. So the approach with Across that Risk Labs has taken is to basically try and keep the on-chain components very simple, and then to have like this network of bots that are doing a lot of the heavy lifting. And that's I think it's an interesting kind of design pattern, and it's got a number of benefits. Like it's ultimately it saves the user's funds because every time a user does an on-chain transaction, every instruction that gets executed has a cost. So by keeping the on-chain contracts quite simple, there's less logic there, and therefore there's less cost for the user to do that. And the other thing is that there's a lot of kind of improvements that can be integrated, like over time, because the bots can become more intelligent. Like the off-chain component of the system can become more intelligent, and you get the benefit of, you can see the system in action, and then you can observe, how it works and make improvements, and that gives a great deal of flexibility. It lowers the risk of problems, and it basically gives you a lot more flexibility, because you can do more advanced things off chain, with different languages and things like this. You've got more flexibility. So these are the things that I find really interesting about Across. And I should also mention that Chris from Risk Labs, who's one of the developers on Across V1 and V2, he actually did a podcast where he explained some of these design kind of paradigms as well. So we might actually link that podcast, because there's some really good content in there as well.
That would be awesome. If you can if you find the link and put it into the stage chat, that would be great.
Yeah, we'll do.
Could you server mute whoever's making that noise?
Dixie, hello.
Hey, yeah.
Yeah, Dixie, I had a small question to you. Like, I mean, since the relayers are the one, like, I mean, doing all the transactions with the help of the bots, uh, how I mean, say in case if there's a hack or a um, um, or a I mean, the protocol goes under the hack, something like that. So only the relayers, the portion of the amount uh, is under risk, right? Rest of the amount, the money stays safe, right?
So I guess there's different scenarios, and I can give like a semi-qualified answer on this. We definitely have, like, there are people in the team who can give really, really excellent answers to this. But basically, it's kind of like as I see it, it's kind of a cascading system. So when a user makes a deposit on a chain, so say a user makes a deposit on Ethereum, and it's destined for Arbitrum, you will have bots which are on the Arbitrum network, and they're monitoring what's going on Ethereum, and they'll see this deposit event turn up. And at that point, they can make a decision about whether or not they want to make a payout instantly on Arbitrum. And when that happens, the relayer implicitly takes a risk that it might not get those funds back. That's like a risk. There's a couple of things that could potentially go wrong there, like just through the system. That relayer's risk is corresponding to the amount of time, basically, or the duration of that risk. Okay, we need to mute somebody. Sorry, 2 seconds. I'll just see who that was. Can anyone see who that user is? Like, I can't see them.
Hare Krishna, I think it's Hare Krishna.
Okay, yeah, I see. I muted him. Muted, yeah, good.
Great.
Yeah, so basically, as a relayer, you send funds out, and then you're sitting without your funds for a period which is typically between like 1 hour and maybe like 5 hours. And that's the cadence of this secondary process, which is called the data worker. And the data worker will go and look at all of the relays that were performed, and it builds them up into a big list, and then it submits that to the contract and says, these are the relayer, or these are the transfers that we think should be compensated, should be refunded. And once that passes the liveness period in the optimistic oracle, then it can go ahead and execute those refunds. So as a relayer, you make a transfer that's like, or your loan that you're making to the person, to the user, is like, that's a period of kind of somewhere between 1 and 5 hours. After you get your refund, then the relayer itself doesn't wear the risk for that transfer anymore. So one of the interesting ideas is with these optimistic L2s, so like Arbitrum and Optimism, like they have a challenge window of like 7 days, is what I understand. So if you're an Arbitrum and you send funds via the Arbitrum bridge back to Ethereum, it can be challenged on like day 6. And if you are a relayer and you're sitting on Ethereum and you have made a fast relay for a transfer from Arbitrum to Ethereum, if you get your funds refunded within that normal 4 to 5 hour window, you are not going to wear the loss of something going wrong on day 6 as the funds are moving back through the Arbitrum standard bridge. So there's kind of layers of risk, and there are different actors in the system. And ultimately, if something goes wrong on day 5, my understanding is it would really be the liquidity providers. Like those are the people who have deposited funds into the L1 hub pool. If something goes wrong on day 5, like those users sit in a situation where the relayer has been compensated, and then there will be no funds arriving back into the pool to account for the compensation for the relayer. So it's kind of it's kind of like a cascading series of risk, and like each different participant in the system will wear different levels of risk depending on what role they are having, and the time duration for their risk will also vary depending on what role they have. So I don't know if that is like
that's an
is that
awesome explanation, Dixie.
okay. That's nice. I mean, I kind of just came up with that one on the fly, but I think that's kind of like how I view it. It's almost like a waterfall kind of process if you can kind of visualize that. So yeah.
Yeah, Dixie, I got it. Like, I mean, so both the relayers as well as the liquidity providers, both are under the risk, right? I mean, after 5th day, in case if something goes wrong, the liquidity providers will come under the mercy, right?
Yeah. So I mean, basically, it's like once the liquidity providers have compensated the relayer, then they are wearing the risk.
Correct.
So that's like up until the fund, like they're expecting funds to arrive across a canonical bridge. If those funds don't arrive for some reason, then it's the liquidity providers who are out of pocket. Another thing to consider though is that like if you're a relayer, you are like either one person. You can be an individual who's acting as a relayer, or you can be an organization. And those are kind of concentrated funds. So whoever is the owner of those funds, as a relayer, if they don't get refunded for their fast relay, then they wear that loss solely. In the liquidity pool situation, like if you're a liquidity provider, like if for some reason a loss of like 1 ether were to occur, that's like that would, I imagine, be distributed uniformly across the pool. So it's also like different levels of risk that gets associated there.
Right, Dixie. Yeah.
Okay, thanks, Dixie SB Singh. Before we move on, anybody else has any questions? Okay, since we're talking about relays, probably a good time to move on to relayers. Let me go back to my screen. I'll go back to the overview. And if you come to docs.across.to, if you're interested about running a relayer, you can come here, and it's got everything you need for running a relayer. And pretty much anybody who's got experience of using a command line or any kind of programs like that, and we'll be able to. I'll go briefly through what it says here, and then I'll show you a short demo. This is like the minimum requirements for your machine, and it is really the minimal. It's very memory intensive, so really the recommended is 8 gig, and I think if I remember rightly, Across is using a 32 gig machine, but obviously it's doing much more than just doing a relay. So really you should be looking at like an 8 gig system. And it's all open source. You can go to the GitHub repository and clone it onto your system. Now, in future workshop, we will go through this step by step, doing everything and on how to actually do the setup. Today is just to show you what the process will be. And you have to create like an environment file. And essentially what you do, you just copy and paste here. And does someone have a question? Sorry. If anybody can find that person and mute, that would be awesome. So this is the environment file. And what you can notice here is it's asking about your wallet. There are other ways and more secure ways of putting in your wallet address or your private key. But when you're starting out, this is what you will do. You put your seed phrase essentially in here, which is a security issue. And again, later on, we will talk about ways to mitigate that. The next thing you do or you need is these endpoints. Now, you will need a provider like Infura or Alchemy to be able to essentially look at what's going on the blockchain. And you need this for every chain that you want to be a relayer for. You need to have a node URL. And for me, I use Alchemy. So I'm just going to show you Alchemy here. So I've set up Arbitrum, Optimism, Polygon, and this Demon Playground is actually just mainnet, the Ethereum. And what you do, you get like an API key, and this is what you need to put into here. So my relay is actually running at the moment. So if I go to the usage, on the free account, you get 300 million computes, which sounds a lot, but it can actually go. And this is how much it's using daily. I'm running my relay about 8 to 10 hours every day. And this is a change actually that the recent code base change for the relayer has actually more than halved the number of computes per day. So I can quite comfortably run this all month and be still under the 300 million compute units. Again, Dixie, I know I'm picking on you a lot. Did you notice this as well since the recent code base changed?
I haven't specifically noticed it, no. But there is a general, like we have a strong interest in improving the performance of the bot. Like at the moment, the Risk Labs has some infrastructure which is really like enterprise level infrastructure. But of course, like the intention is for like end users or individuals to be able to do this as well. So there's like a bit of a push to increase the efficiency of some of the resource usage of the bot. So I'm not sure whether this falls under that, but
I
there's
think it
definitely
must
some.
do, because a couple of weeks ago when I was running it, it was like between 10 and 14 million computes per day.
That's interesting. I wasn't aware of that, but yeah, it's actually one of my things to look at, is to try and see if we can get it down even further. So
Yeah. But this is really good. So if I go back to my environment file, so you need to set up these nodes, and so you'll need an account with one of these provider. I've gone with. Oh, did someone want to say something? Sorry.
Yeah, Neon. I was just gonna say, could you go into what kind of explain what computes are for everybody, so they can more understand of what they'll be using when they do, why they do need to use, alchemy or and such.
Yes, sure. So essentially, what you are doing, you are. So when someone deposit on Optimism, that's an event on the Optimism chain. And what you essentially need to do as a relayer, you need to be monitoring all the transactions that are happening on all these different chains, and you're looking out for or monitoring when someone has deposited, because you're interested in relaying that on the chain that they want to go to. So you need to be active on all these chains, and the computes it's interrogating, or yeah, interrogating, for want of a better word, the actual transaction history on that blockchain, and that's essentially what it's doing. So you need to, you can't, you could do this manually, of course, but obviously practically that's not possible. So by going to one of these infrastructure providers, they will allow you to do this by giving you an API that does it automatically for you. Okay, so moving on. The next option here is send relays equal true. That means it's live. When you first start out, it's a good idea to set it to false and just make sure everything's working. The next thing to set up is Redis, and this is so, and Dixie and I were talking about it just now, is about we want to not go to Alchemy or Infura, whoever your provider is, so much. So this acts as a cache, and it reduces the number of computes that you have to go out and get. The next things which I've been playing around with, and I'll show you that in a minute, is how far back the transaction history do you want to look back? If you're a big provider, or if you have lots of funds, you can maybe look back quite far back. I think it's like 1 day even, or even longer. Here it says approximately 2 days. But if you are low liquidity provider, relayer like myself, then I've been playing around with these numbers, just trying to see if I can be quicker to the relays. So it is, the relayers are competing against each other to get to do the relays, because obviously the more you do, the more you can earn. The advanced configurations, the only things I've done is, because Alchemy doesn't do Boba network, I'm not doing that. So these are the destination chains. I've started learning what the numbers mean now. So 1 obviously is Ethereum, then Optimism. 137 is Polygon. 288 8. I think that's is that Boba? Someone can help me. And 42161 is Arbitrum. You've got backup node providers here, and yeah, so we won't go through everything here now. So let me. What I want to do next is just go through a demo. So let me stop streaming that. Okay, so earlier today, so welcome to my relayer. Can you just confirm that you can see it okay?
I cannot see it right now. Should I try to exit it and come back? It says stream paused. Neondaemon has minimized their application. Sit tight.
Haha, have I?
It's loading now. Same thing.
Yeah, I also see stream pause. I just I guess be really really careful that you don't reel your seed phrase here as well, because that's something that something can happen to the best of us, I guess.
Cricket noise.
Just while we're waiting, I'll also mention before you pulled up that that docs page, or just after you pulled it up, actually, there's just been pushed an update. So there's a new section that covers security considerations, and it's basically just an effort to highlight to people that there is implicitly a security risk when you're running a bot. Like funds are at risk, and things can go wrong, and funds can disappear if the wrong thing happens. So it's just like that's kind of an unavoidable thing, and what we've tried to do is to just document for people some of the things that they should consider, and some kind of like high level tips as to what you might be able to do to improve your security. So it's not like a be all and end all guide, but at least it's intended to kind of prompt for you, for individuals, some of the considerations that they need to be thinking through when they're considering whether or not they want to operate a bot.
Dixie, where'd you say that's documented?
Should be on the docs.across.to. I believe it's up there now. I'm just going to check. Okay, it hasn't actually updated it. I'll just have to fix that quickly.
Yeah, if you wouldn't mind maybe linking it once it's updated, that would be appreciated.
Yeah, no problem.
I don't want to, Neon, I don't want to, I don't know, I guess I had a separate question, but I don't want to interrupt some of your conversation.
Oh, right. Carry on. I think you can see my screen now as well.
Let's see. I'm going to click it. It's loading. So I guess for Neon or Dixie, I had kind of an idea about using a yield aggregator to have basically a managed relayer provide yield for doing something like this. But in regards, I know obviously there's some kind of components of what that management process would look like, and probably even more security risks. I know one of the things that was mentioned, I think briefly today and previously, was having the wallet key phrase being I guess stored on the server. Could you guys just talk? Are we talking about like the local server on the machine you're running the relayer on, and that risk, or is there another component with that piece of the risk specifically? And if so, could you explain it?
Yeah. So I'll just link the section. It looks like the page is updated now. So if you do like a hard refresh in Discord, hopefully hopefully you'll see it. But I can also just drop it in the chat. Yeah. But predominantly the description that's there is relating to the physical, like it's the execution environment of the bot, and it's also the physical slash logical environment. So like in my case, like I have a physical machine at my house, but many people want to run this in the cloud. And so when you're doing this in the cloud, like implicitly, like someone else is hosting that computer, and they would therefore have potential to kind of maybe go and look at the disk and see what's on it. So there's basically just making it explicit that like if someone's got physical access, then that allows them to do certain things with your system, and that's kind of the implication is that if someone has physical access, then you implicitly must be trusting that person. Physical or logical access to it. And then there's a couple of other points in there. Predominantly at this point, it's focusing on like making sure who's got access and understanding that when you have something saved to your disk, like certain actors might be able to get at that, have specific level, certain levels of access. The second thing was that there's a challenge that this, if you've got an organization where there's multiple people who want to be kind of jointly administering a bot, that's like a really difficult problem to solve because ultimately someone needs to be trusted with this keying material. So that's like a harder challenge to solve. Like we've had quite some discussions about this, with the community, just hearing some of the feedback, and it's like some of these things are not across relay bot problems. They're like really general problems that are kind of just inherited by what we're doing here. But it's basically something that might evolve. Like, I mean, these are hard problems that people are working on. There are some kind of solutions that people can use to hold their key material and kind of extract them from some other third party service. So there's different options. There's no like silver bullet. But yeah, like the objective of the kind of section that's gone in at the moment is just to explain to people like this is not quite as simple as you just download the code and run it. Like there are certain things that you should really be considering in advance, to just make sure that people go into this being informed of the risks. So
Yeah, no, I appreciate that. That's really helpful. I think recognizing the potential like trust factor and other considerations with like a group managed or like a managed and then depositor components of that. I fully appreciate that piece. I think where my head was at is understanding, I think have had some conversations in the community about the importance of both liquidity and relayers. And fast forward as we see growth and more volume, I can see a synergistic relationship of like having more or larger relayers present and almost treat it like a managed vault through a harvest or urine or someone and let them figure out some of those components, right? Where maybe you have to time lock deposits or withdrawals, or there's obviously a trusted component and acceptance of other risks and things. But I think there's potential there for some interesting dynamics at play.
Yeah, I mean, it's certainly very interesting, and I mean, there are some hard problems in there, but it's really good to hear that people are considering them for sure. I mean, there have been periods where the Risk Labs operated relayer bots have run short of liquidity in different points in time, because there's been extreme demand, and I think that the launch of the referral program was like probably the most recent instance of that, where it generated so much demand that even though the Risk Labs relayer bot is pretty deep in liquidity in most chains, it still kind of pushed it to the limit for a couple of days, and that would have been like a really interesting opportunity, or like it would have been interesting at that point to see like this other network of bots come online to soak up some of that demand, because I think the reality is that at that point there was probably some good money to be made as a relayer. It's I think that there is definitely, like, the more decentralized the relay network is, the more elastic Across can be to periods of peak demand.
Mm-hmm.
And that's like good for users, and it's good for relay operators, and it's good for LPs. It's good for everybody. That would be it's definitely having a broader relay network is something that's quite exciting, I think.
Yeah, thanks. I appreciate the extra detail there.
Thanks, guys. That was cool. I think you can see my screen now, right?
Yes, sir.
I'm just loading your seed phrase into my wallet.
Awesome. Did you read it?
Yeah, I did. I'm already draining your account. Thanks.
So we won't get into all the setting up. Like I said, this will be in the next workshop. Maybe we'll do all the setup. But this is something I was running it on this machine earlier today, and I've got set up with my nodes and everything. And on the left-hand side, you can see that I'm running the Redis server, which is going to cache every so often. This means I don't have to go out to Alchemy as often, and it reduces the number of computes that I need to do. And one of the recent things they've got enable profitability. That's fairly new. Before you could do like a discount, but now and this is I learned from Dixie as well. It used to be like you had to have a profit of at least $1, but now as long as you are making any kind of profits, like a few cents even, then it will do the transaction. And I have proof of that in the last few days. With my 1,000 USDC, I've made 37 cents, 25 cents, and there was one that I made over $5, but then 24 cents and 61 cents during the time it was running. So it's not hugely profitable, but it's making something. And these are all my configurations that I'm just going through briefly. My destination chains, I'm not doing Ethereum because that costs too much. I'm just sticking to Optimism, Polygon, and Arbitrum. And very shortly, I'll be running my so I can speed it up. Oh, so I went a bit too fast there. So all this always starts off, and then it will just start going now. So the actions has started. Can someone server mute that, please? Right, so it's connected to the Redis server, and now it's going through my environment file and just using that as the basis for setting it up.
Neon, I've got stream paused. I don't know.
Oh, have you?
Yeah, I'm not sure if anybody else has that on their screen.
Yeah, I do too. It says you've minimized their application, so then it pauses the stream.
Is it working better now? Is it still paused?
Yes. Yeah, I still have it as paused.
No.
It says due to network conditions, so maybe it says the stream you're viewing has reduced video or audio quality, so maybe it's your network. I did want to bring up the profitability aspect of it. Then that is your profitability with paying the gas fee. Am I correct? If I'm correct, I believe so. That you're still making a profit. You're not you're not filling anything with and losing out and paying more in gas than you would than you get back in fees. Am I correct on that?
Can you see my screen now? Yeah.
Yes, sir.
Awesome. So yeah, so it's going through and looking at deposits, and if I move it a bit further, right, we're kind of out of time, so I'll just move on further. And now it's, if you look at it, it's found some things that possibly I can fill. Okay, and I had a few errors here, and I think it was to do with it couldn't work out what the gas costs were. I don't know if Dixie can help out. And if I stop it on this one, and one of the issues that I have is I have very low liquidity on my relays. I've got 1000 USDC and 0.36 of an ETH. So there were lots of things here I could possibly have filled, but because I don't have that much funds in my wallet, it doesn't. Since this, I have made a few transactions. It has done some, but when I was running the tests earlier, it didn't actually fill anything. But there are opportunities here. So the capital that you would need, I would think, is going to be, in terms of USDC, is going to be 5,000 to 10,000 USDC probably. Because 1,000 you can make something, but not a lot. And again, with ETH and WETH, then again, the more you have, the better it is. So yeah, I get this a lot: insufficient balance to fill all deposits. And I think at the end it was like, I'm shortfall of $849,443. So yeah, I didn't have that amount, unfortunately. So one day maybe. So that's the kind of demo of the relayer. In our next workshop, hopefully, we will go from just the very basics, what the prerequisites are, how to install it, how to configure it, and we'll go through all that. Does anybody have any last questions or thoughts?
Yeah, and I'm not sure if you heard me when I asked earlier, but I was trying to explain that the profitability, and what that does is it makes sure that you're not spending more gas than you are receiving. If I'm correct, right?
That's right.
Okay.
Yeah. So depending on the gas costs, it will work out whether you will actually make any profit at all. And it used to be you had to make at least $1. If you weren't making a dollar, then it won't actually go through. Now it's kind of changed, and as long as you are making a profit, it will it will let the transaction go through. In future, though, again, this is from Dixie. They may have, like, you can set it so there will be a minimum that you need to earn that you could set for yourself. But at the moment, it's anything that's profitable, it will actually do it.
Which is a great security kind of setup or backstop for you're not sleeping at nighttime with this running and doing transaction after transaction with spending more gas than you are receiving fees.
Yeah, indeed, it won't allow that. So yeah. Right. Okay. Anybody else with any questions?
If we wanted to estimate the return you'd get on deposits by running the relayer, what would be the best way to go about estimating that?
Right now, I'm not. I can do that. I've been told, like for example, for USDC and WETH, it was between like 30-40% return you could get on this. But in terms of the statistics, I'm not sure how to get that. What I'm doing is just working out how much I'm getting per day, and then over time, I'm going to work out how much profitability my 1,000 USDC is. In kind of the 3 weeks I've been running it, not like I think I've earned like $15 on a $1,000 thing. So that's in 3 weeks. So you can actually extrapolate that out. Of course, if I had more funds, say 10,000 USDC or 100,000 USDC, then I would probably be looking at making many more transactions and potentially much more profit.
Can I add something to that?
Please.
So I guess the way to kind of work it out would be to look at in the docs. It shows that there's like a minimum fee that is charged to the liquidity pool. So that kind of gives you a guide as to what the user is charged per transaction. So if you take the minimum is like 0.03%, you can say it's roughly around that per transaction. So obviously, as Neon just said, depending on the volume and number of transactions you're doing, like how much volume you're putting through is going to be the multiplier to kind of get a prediction.
Yeah, cool. Thanks.
A good question. Thank you very much for that, and thank you, GR, for stepping in there. Well, we're a few minutes over, so thank you very much for everyone. This was like a Crossbridge 101, and it's very much like an introduction into the Crossbridge and relayers. And hopefully soon we'll do another workshop where we'll actually go through a bit more technical, and we'll go through doing the setting up of the relayers and activate it and making it work. And if anybody else wants to become like a relayer, it's awesome. We have a meeting every 2 weeks. We just had one this Wednesday, so the next dev meeting will be in 2 weeks' time. 2 weeks yesterday. And also, this video is being recorded and will go onto the SuperUMAn YouTube channel when Deadcoy does all his fancy video editing. We'll post it in the cross. And thank you very much for joining us.
Thank you, Neon.
Thanks, Neon.
Thanks a lot. Cheers.
Cheers,
Bye.
guys. Bye bye.
See you guys.
Thank you.
Thank you. Bye.